Larry Jeffers Race Cars, Project Parrotfish Scheduling with Measurable Details Introduction. Larry Jeffers Race Cars, LJRC, is creating a detailed project schedule for Project Parrotfish, their new high-performance race car. The schedule will outline the tasks, timelines, dependencies, and resource allocation required to complete the car on time, 180 days, and within budget, $2 million. Importance of project scheduling for Project Parrotfish. Measurable benefits: reduced rework costs. A clear schedule with defined task ownership, RAM, will minimize errors and miscommunication, leading to a target of 5% or less rework costs compared to the project budget. Improved resource utilization. Resource allocation will be optimized to avoid under-allocation. Target, less than 10% idle time for engineers and mechanics, and over-allocation. Target, no more than 10% overtime per week. Early identification of delays. Weekly progress tracking against the schedule will allow for proactive intervention. The goal is to identify and address potential delays at least 2 weeks before they impact critical path tasks. Enhanced cost control. Schedule adherence will minimize cost overruns. The target is to maintain project costs within 5% of the allocated budget. Project scheduling techniques for Project Parrotfish. Critical Path Method, CPM. This will be used to identify the critical path. The target is to have a critical path buffer of at least 5 days to absorb unforeseen delays in critical tasks. Fast tracking with simulation. LJRC will explore fast-tracking non-critical path activities, for example, some exterior component fabrication, if delays occur in critical tasks, for example, engine assembly. Monte Carlo simulation will be used to assess the impact of different fast-tracking scenarios on project duration and resource requirements. Steps to create an ideal project schedule for Project Parrotfish. Measurable details. List tasks. Refer to the WBS to identify all project tasks. Each task will have a specific owner assigned and a measurable deliverable. For example, lead aerodynamics engineer delivers finalized aerodynamic design documents. Determine task relationships. Analyze dependencies between tasks. Quantify lead times for materials and external services, for example, 4 weeks for custom engine parts. Assign team members. Assign ownership for each task based on expertise. Consider team member capacity and workload throughout the project. Estimate task durations. Estimate the time required to complete each task considering resource availability and task complexity. Use 3-point estimates, optimistic, most likely, pessimistic, to account for uncertainties. Consider scheduling factors, constraints, project deadline, 180 days, budget, $2 million. Assumptions. Lead times for materials are clearly defined, for example, 2 weeks for standard parts. Delays. Allow buffer time in the schedule for potential delays due to unforeseen technical challenges. Target, 10% buffer on critical path tasks. Risks. Identify resource limitations and unexpected cost increases. Develop mitigation plans to address these risks, for example, securing a backup supplier for critical parts. Team availability. Account for team member vacations and training needs. Schedule tasks accordingly to minimize disruptions. Include contingency. Allocate buffer time, 10%, to the overall schedule to account for unforeseen events. Identify critical path. Use CPM to identify the critical path tasks. Analyze the critical path buffer and implement risk mitigation plans if necessary. Manage resource allocation. Track resource allocation throughout the project using a resource management tool. Monitor for over-allocation or under-allocation and adjust task assignments or schedules as needed. Refine and iterate. The project schedule is a dynamic document. As the project progresses, the schedule will be refined based on actual progress, identified risks, and lessons learned. Weekly meetings will be held to review progress and update the schedule. Monitoring and tracking progress. A project management software will be used to track task completion rates, resource utilization, and budget variances. Schedule Performance Index, SPI. This metric will be used to assess whether the project is on schedule. A target SPI of greater than 0.95 indicates the project is on track. Earned Value Management, EVM. This methodology will be used to track project progress against the budget. The target is to maintain a positive Cost Performance Index, CPI, throughout the project. By implementing these detailed scheduling practices with measurable targets, Larry Jeffers race cars will significantly increase their chances of completing Project Parrotfish on time, within budget, and to their performance specifications. Larry Jeffers Race Cars, putting PMBOK Guide 7th edition into practice. Larry Jeffers Race Cars, LJRC, exemplifies how the PMBOK Guide 7th edition can be applied to optimize their custom race car builds. Here are illustrative scenarios using the key points you mentioned. 1. Project Portfolio Management System for Value Delivery. Scenario: LJRC is juggling multiple projects simultaneously, including building a pro-modified dragster for a first-time customer aiming for a 6-second ET, elapsed time, at the season opener, and a top sportsman car for a veteran racer seeking a back-to-back championship win. Both projects contribute to LJRC's portfolio but have different goals. Metrics: success for the new customer is achieving a 6-second ET within a set budget. For the veteran racer, it's winning the championship. Value delivered. LJRC tracks project profitability and customer satisfaction to measure overall portfolio performance. 2. Importance of soft skills. Scenario: during the pro-modified build, disagreements arise between the fabrication and engineering teams regarding material selection for the chassis. The project manager facilitates a collaborative discussion, ensuring clear communication and buy-in from both sides. Metrics: improved team communication is measured through team surveys and reduced project delays due to conflicts. Additionally, staying on budget due to efficient collaboration demonstrates the value of soft skills. 3. Navigating complexity, adaptability, resiliency. Scenario: mid-build on the top sportsman car, the team discovers a critical component incompatibility. The project manager quickly assembles a cross-functional team to brainstorm solutions. They leverage their experience, adaptability, to identify alternative parts from their LJRC1 performance parts division and revise the build schedule, embracing change. Metrics: adaptability is measured by the time it takes to identify and implement a solution. Additionally, the project manager tracks the impact on the overall project timeline and budget due to this unforeseen complexity. 4. Tailoring project management practices. Scenario: for the new customer's pro-modified car, LJRC utilizes a waterfall project management approach due to the well-defined requirements and focus on achieving a specific ET metric. This allows for a structured build process with clear milestones. Metrics: success is measured by on-time delivery of the car within the agreed-upon budget and achieving the 6-second ET target during initial testing. Overall, by applying the PMBOK Guide 7th edition's principles, LJRC can effectively manage its project portfolio, ensuring each custom race car meets or exceeds client expectations. The focus on communication, adaptability, and tailoring project management practices to each build's unique needs allows LJRC to deliver high-performance cars while maintaining efficiency and profitability. The 7th edition introduces new concepts such as project portfolio management, system for value delivery, and tailoring project management practices based on context. The 7th edition emphasizes the importance of soft skills such as collaboration, communication, and stakeholder engagement. The 7th edition also highlights the importance of navigating complexity, embracing adaptability and resiliency, and enabling change. The speaker recommends tailoring project management practices to the specific context of the project, considering factors such as the team, the development approach, and the company culture. Overall, the video provides a helpful overview of the PMBOK Guide 7th edition and its key changes from the 6th edition. Here are the names that represent the Clownfish outputs from other planning processes, for the planning phase of project management. Lionfish, project scope baseline, defines the project's scope, including deliverables, assumptions, and constraints. Dragonfish, project schedule baseline, defines the project's schedule, including milestones, dependencies, and critical path. Angelfish, project cost baseline, defines the project's cost, including estimates, budgets, and contingency reserves. Frogfish, scope management plan, describes how the project scope will be defined, verified, and controlled. Parrotfish, schedule management plan, describes how the project schedule will be developed, monitored, and controlled. Mandarin fish, cost management plan, describes how the project costs will be planned, estimated, budgeted, and controlled. Blobfish, risk management plan, describes how risk management activities will be planned, identified, analyzed, and controlled. The Clownfish inputs, along with the Lionfish project charter and other planning inputs, are used to develop the integrated project management plan that defines how the project will be executed, monitored and controlled. The exotic fish names add a unique and a memorable flair to these key planning outputs. Here are exotic fish names applied to each input in the planning phase of project management. Lionfish, Project Charter provides a high-level description of the project, objectives, success criteria, schedule, budget and risks to guide initial project planning. Clownfish, outputs from other planning processes, includes baselines, scope, schedule, cost, and subsidiary management plans, scope, schedule, cost, risk, etc., that are integrated to create the overall project management plan. Blobfish, enterprise environmental factors. Relevant factors include government regulations, industry standards, organizational structure, facilities, and existing systems that influence how the project is planned. Mandarin fish, organizational process assets, includes policies, processes, templates, lessons learned, and historical information from previous projects that provide a foundation for planning. Seahorse, requirements. Detailed requirements documentation provides key inputs for planning the scope, schedule and resources needed to fulfill the project's objectives. Frogfish, stakeholder information. Understanding stakeholder needs, expectations and influence helps shape the project management approach. Parrotfish, agreements, existing contracts, memorandums of understanding, etc. define constraints and assumptions for project planning. Dragonfish, institutional data, historical data on similar projects, productivity metrics, and cost rates inform estimates and planning. These exotic fish inputs, along with expert judgment, data gathering techniques, and interpersonal skills, are used to develop the integrated project management plan that defines how the project will be executed, monitored and controlled. Dragonfish, a concept proposal for a revolutionary new race car project, named after the exotic and powerful dragonfish. Clownfish, a business case for the Dragonfish race car, named after the colorful and charismatic Clownfish. Angelfish, a benefits management plan for the Dragonfish project, named after the graceful and serene Angelfish. Blobfish, a document analyzing enterprise environmental factors for the Dragonfish project, named after the bizarre and unattractive Blobfish. Mandarin fish, stakeholder register templates for the Dragonfish project, named after the vibrant and patterned Mandarin fish. Frogfish, a repository of lessons learned from previous projects, named after the camouflaged and ambush hunting frogfish. Lionfish, a project charter authorizing the Dragonfish race car project, named after the venomous and majestic lionfish. These exotic fish names add a unique and a memorable flair to the files, while still referencing key terms and concepts from the world of drag racing. The Dragonfish, Clownfish, and Lionfish in particular evoke a sense of speed, power, and innovation that perfectly captures the spirit of the sport. Here is a story about fictional Larry Jeffers race car company that incorporates the exotic fish names representing key project management inputs. The Parrotfish Racing Revolution. Larry Jeffers, the visionary behind Parrotfish Racing, was known for his relentless pursuit of innovation. One day, he walked into the office clutching a peculiar file, the Lionfish Project Charter. This critical deliverable authorized a groundbreaking new race car project and identified the key stakeholders who would bring it to life. Larry knew he needed a compelling Clownfish business case to win over investors and the team. The proposal promised blistering speed, superior handling, and game-changing aerodynamics that could disrupt the entire racing industry. Using the Mandarin fish stakeholder register templates, Larry's team identified key players like sponsors, suppliers, the pit crew, and the engineering wizards who would bring this vision to life. They consulted the Frogfish lessons learned repository from previous projects to avoid past pitfalls. With funding secured, a buzz of excitement rippled through the Parrotfish Racing headquarters. In a small but mighty workshop, the engineering team toiled day and night, innovating and iterating relentlessly. Months of tireless effort culminated in the unveiling of the Parrotfish X1, a technological marvel that defied conventions. As the X1 took to the track, leaving a trail of stunned competitors in its wake, Larry Jeffers knew he had a winner. Thanks to diligent initiation inputs like the Lionfish Project Charter and Clownfish business case, Parrotfish Racing had launched itself into a new era of dominance. The Mandarin fish stakeholder register templates were crucial for identifying and engaging the right people at the right time. By mapping out the power and interest of each stakeholder, Larry's team could tailor their communication and management strategies for maximum impact. Just as the Lionfish Project Charter authorized the project and the Clownfish business case secured funding, the Mandarin fish stakeholder register served as the foundation for successful stakeholder management throughout the race car's development. It ensured that everyone from the sponsors to the pit crew was aligned, informed, and empowered to contribute to the project's success. The Parrotfish Racing story demonstrates the importance of identifying stakeholders early on using tools like the Mandarin Fish Register. By understanding who has a stake in the project and how to engage them effectively, project managers can navigate the complex web of relationships and steer their initiatives to victory, just like Larry Jeffers and his revolutionary Parrotfish X1. The Parrotfish Racing Revolution. Larry Jeffers, the visionary behind Parrotfish Racing, was known for his relentless pursuit of innovation. One day, he walked into the office with a gleam in his eye and a file in his hand. This file, dubbed the Dragonfish, was a concept proposal that outlined a groundbreaking plan to develop a new race car that would set the racing world on fire. Larry knew that to turn this dream into reality, he needed a solid foundation. The first step was to create a compelling Clownfish business case. This document would detail the project objectives, potential market impact, and an initial list of stakeholders who would be affected by this ambitious endeavor. Next, Larry and his team crafted the Angelfish Benefits Management Plan. This plan identified the stakeholders who would benefit from the project outcomes, ensuring that everyone from the investors to the pit crew understood the value this new race car would bring. But Larry was no stranger to the complexities of the racing industry. He knew that Blobfish enterprise environmental factors, such as government regulations, industry trends, and organizational culture, could influence the project's success. Therefore, he made sure to analyze these factors thoroughly. To streamline the process, Larry's team utilized Mandarin fish stakeholder register templates. These templates helped them identify and document key stakeholders, ensuring that no important player was overlooked. They also consulted the Frogfish Lessons Learned repository, drawing on past experiences to avoid previous mistakes and optimize their approach. With these primary inputs in place, Larry produced the Lionfish project charter. This critical deliverable authorized the project, identified the project manager, sponsor, and initial stakeholders, and set the stage for the journey ahead. The initiation phase was a whirlwind of activity. Larry and his team focused on analyzing the business need, defining a high-level scope, and conducting feasibility studies. The Clownfish business case was developed meticulously, outlining the project's potential and securing the necessary approvals to move forward with detailed planning. Properly identifying and analyzing stakeholders from the outset using inputs like the Dragonfish concept proposal was crucial for the project's success. Larry's team knew that engaging the right people at the right time would make all the difference. Months of hard work and dedication culminated in the unveiling of the Parrotfish X1, a race car that embodied innovation and excellence. As the X1 roared down the track, leaving competitors in its dust, Larry Jeffers knew that his meticulous planning and strategic use of inputs had paid off. Parrotfish Racing had not only launched a new race car but had also set a new standard in the racing industry. Thanks to the Dragonfish, Clownfish, Angelfish, Blobfish, Mandarin fish, and Frogfish, Larry's vision had become a reality, and Parrotfish Racing was poised for a new era of dominance. Here is a story about Larry Jeffers' Race Car Company, incorporating the exotic fish names representing project inputs. It was a sunny afternoon at Laguna Raceway when Larry Jeffers, the eccentric owner of Parrotfish Racing, strolled into his office clutching a peculiar file. This Dragonfish concept proposal outlined an ambitious plan to develop a revolutionary new race car using cutting-edge technology. Larry knew he needed to build a strong Clownfish business case to convince investors and stakeholders. The proposal promised blistering speed, superior handling, and game-changing aerodynamics that could disrupt the entire racing industry. His team got to work, analyzing the Blobfish enterprise environmental factors like government regulations, market trends, and the company's risk appetite. They consulted the Frogfish Lessons Learned repository from previous projects to avoid past pitfalls. Using the Mandarin fish stakeholder register templates, they identified key players like sponsors, suppliers, the pit crew, and the engineering wizards who would bring this vision to life. An Angelfish benefits management plan outlined how each stakeholder group would reap rewards from the success of this audacious endeavor. Despite some initial skepticism, Larry's infectious enthusiasm and the compelling Clownfish business case won over the board. With funding secured, a buzz of excitement rippled through the Parrotfish Racing headquarters. In a small but mighty workshop, the engineering team toiled day and night, innovating and iterating relentlessly. Months of tireless effort culminated in the unveiling of the Parrotfish X1, a technological marvel that defied conventions. As the X1 took to the track, leaving a trail of stunned competitors in its wake, Larry Jeffers knew he had a winner. Thanks to diligent initiation inputs like the Dragonfish and Clownfish, Parrotfish Racing had launched itself into a new era of dominance. Here are the key inputs to Phase 1, Initiation Phase, Concept Proposal, Dragonfish. Business Case, Clownfish. Benefits Management Plan, Angelfish. Enterprise environmental factors, Blobfish. Organizational process assets, stakeholder register templates, Mandarin fish. Lessons learned repository, Frogfish. The Dragonfish, concept proposal, Clownfish, business case, and Mandarin fish, stakeholder register templates, serve as the primary exotic fish inputs for initially identifying key stakeholders during the initiation phase. The Lionfish, project charter, is also a critical deliverable produced in this phase that authorizes the project and identifies the project manager, sponsor, and initial stakeholders. The initiation phase focuses on analyzing the business need, defining a high-level scope, conducting feasibility studies, developing the Clownfish business case, and obtaining approval to move forward with detailed planning. Properly identifying and analyzing stakeholders from the outset using inputs like the Dragonfish concept proposal is crucial for project success. The key inputs for Phase 1, initiation phase, of the project management life cycle according to the provided sources are: concept proposal, describes the need or opportunity to improve existing business functions using technology. It highlights unmet strategic goals and identifies needed improvements. Business case, identifies project objectives and an initial list of affected stakeholders. Benefits management plan, identifies stakeholders who will benefit from the project outcomes. Enterprise environmental factors, such as government standards, industry trends, organizational culture, etc. that may influence stakeholder identification. Organizational process assets, stakeholder register templates, lessons learned repository from previous projects with information on stakeholder involvement. The concept proposal, business case, and organizational process assets serve as the primary inputs for initially identifying key stakeholders during the initiation phase. The project charter is also a critical deliverable produced in this phase that authorizes the project and identifies the project manager, sponsor, and initial stakeholders. The initiation phase focuses on analyzing the business need, defining a high-level scope, conducting feasibility studies, developing the business case, and obtaining approval to move forward with detailed planning for the project. Properly identifying and analyzing stakeholders from the outset is crucial for project success. The Lionfish is a particularly fitting name for the project charter, as it is a striking and venomous fish that serves as the initiating document and starting point for identifying key project stakeholders. The Dragonfish and Seahorse also have unique and memorable characteristics befitting the important role of the project charter. Some other exotic options like the Frogfish, Triggerfish, Scorpionfish, and Pufferfish evoke a sense of the project charter being an essential and formidable input that lays the foundation for stakeholder identification. The key inputs for the 13.1 Identify Stakeholders process according to the PMBOK guide are: Project Charter contains a list of key stakeholders and their responsibilities, which serves as a starting point for identifying stakeholders. Business Documents, business case, identifies project objectives and an initial list of affected stakeholders. Benefits Management Plan, identifies stakeholders who will benefit from the project outcomes. Project Management Plan, Communications Management Plan, contains information on how to communicate with stakeholders. Stakeholder Engagement Plan, identifies strategies and actions to engage stakeholders. Project Documents, Change Log, may introduce new stakeholders or changes to existing ones. Issue Log, may identify new stakeholders or changes to existing ones. Requirements Documentation, provides information on potential stakeholders relevant to project requirements. Agreements, parties involved in agreements like procurement contracts are stakeholders. Enterprise environmental factors, such as government standards, industry trends, etc. Organizational process assets, stakeholder register templates and instructions from previous projects. Lessons learned repository with information on stakeholder involvement. The project charter, business documents, and organizational process assets serve as the primary inputs for initially identifying stakeholders in this process. Here are the key inputs to the 13.1 Identify Stakeholders process: Project Charter, Lionfish. Business Documents, Business Case, Clownfish. Benefits Management Plan, Angelfish. Project Management Plan, Communications Management Plan, Discus. Stakeholder Engagement Plan, Triggerfish. Project Documents, Change Log, Frogfish. Issue Log, Scorpionfish. Requirements Documentation, Seahorse. Agreements, Pufferfish. Enterprise Environmental Factors, Blobfish. Organizational Process Assets, Stakeholder Register Templates and Instructions, Mandarin fish. Lessons Learned Repository, Dragonfish. The Lionfish, Project Charter, Clownfish, Business Case, and Mandarin Fish, Stakeholder Register templates, serve as the primary exotic fish inputs for initially identifying stakeholders. Larry Jeffers Race Cars, gearing up for efficiency with a Gantt chart. Larry Jeffers Race Cars is experiencing a surge in demand for their high-performance vehicles. To meet this challenge, they're implementing a new inventory management system and expanding their warehouse space. A Gantt chart will help visualize their project plan and ensure a smooth rollout. Scenario: implementing a new inventory management system, IMS. Horizontal axis, weeks, start date, June 10, 2024. Vertical axis, tasks. Task 1, vendor selection contract negotiation, duration, 2 weeks, bar starts at week 1 and ends at week 2. Task 2, software installation data migration, duration, 3 weeks, bar begins at the end of week 2, dependent on task 1 completion, and finishes at week 5. Task 3, employee training, duration, 1 week, bar starts at week 4, can partially run parallel to task 2, and concludes by week 5. Milestone 1, system go live, week 6, represented by a diamond at the end of week 5. Task 4, post-implementation support, duration, ongoing, bar starts at week 6 and extends beyond the chart, indicates continuous task. Measurable metrics. Task completion rate, track the percentage of tasks completed on schedule each week. Aim for 100% completion to stay on track. User adoption rate, monitor the percentage of employees actively using the new IMS after launch. Target user adoption rate of 80% within 2 weeks of go live. Inventory accuracy, measure the accuracy of inventory data post-migration. Aim for a 99% accuracy rate within 1 month of system implementation. Benefits of using a Gantt chart. Improved communication, the visual plan clarifies task dependencies and timelines for all stakeholders, management, IT, employees. Enhanced project management, Gantt chart allows for efficient resource allocation and identification of potential bottlenecks. Progress tracking, the chart provides a clear view of project progress, highlighting areas that may require adjustments. Additional considerations. Task dependencies. The Gantt chart effectively shows that some tasks, like training, can occur partially alongside others. Data migration. Project milestones. The go-live date, milestone 1, serves as a critical checkpoint for project success. By leveraging a Gantt chart, Larry Jeffers Race Cars can ensure a well-coordinated and measurable transition to their new inventory management system, keeping their operations running smoothly and efficiently. Larry Jeffers Race Cars, gearing up for efficiency with a Gantt chart. Larry Jeffers Race Cars is experiencing a surge in demand, and to meet this challenge, they're implementing a new inventory management system, IMS, alongside a warehouse expansion. A Gantt chart will help visualize their project plan and ensure a smooth rollout. Scenario 1, implementing a new inventory management system, IMS. Horizontal axis, weeks, start date, June 10, 2024. Vertical axis, tasks. Task 1, vendor selection contract negotiation, duration, 2 weeks, bar starts at week 1 and ends at week 2. Measurable metric, negotiate a contract with a cost reduction of at least 5% compared to the previous system. Task 2, software installation data migration, duration, 3 weeks, bar begins at the end of week 2, dependent on task 1 completion, and finishes at week 5. Measurable metric, migrate 98% of inventory data with 0 critical errors by the end of week 5. Task 3, employee training, duration, 1 week, bar starts at week 4, can partially run parallel to task 2, and concludes by week 5. Measurable metric, train 80% of warehouse personnel to achieve a score of 85% or higher on a competency test by the end of week 5. Milestone 1, system go live, week 6, represented by a diamond at the end of week 5. Task 4, post-implementation support, duration, ongoing, bar starts at week 6 and extends beyond the chart, indicates continuous task. Scenario 2, warehouse expansion project. Horizontal axis, weeks, start date, June 10, 2024. Vertical axis, tasks. Task 1, secure permits construction plans, duration, 4 weeks, bar starts at week 1 and ends at week 4. Measurable metric, obtain all necessary permits for construction by the end of week 4. Task 2, procurement of materials equipment, duration, 3 weeks, bar starts at week 2, partially overlaps task 1, and ends at week 5. Measurable metric: procure all materials and equipment within budget by the end of week 5, with no more than 5% variance. Task 3, construction installation, duration, 8 weeks, bar starts at week 5, dependent on completion of tasks 1-2, and ends at week 13. Measurable metric: complete construction according to the plan with a maximum delay of 2 days by week 13. Task 4, warehouse layout organization, duration, 2 weeks, bar starts at week 11, partially overlaps task 3, and ends at week 13. Measurable metric: implement a new warehouse layout that reduces picking time by 10% within 2 weeks of construction completion, by week 15. Milestone 2, warehouse operational, week 15, represented by a diamond at the end of week 15. Benefits of using Gantt charts: improved communication. The visual plan clarifies task dependencies and timelines for all stakeholders, management, contractors, employees. Enhanced project management. Gantt charts allow for efficient resource allocation, identification of potential bottlenecks, and tracking progress against measurable goals. Clear progress tracking. The chart provides a clear view of project progress, highlighting areas that may require adjustments. By leveraging Gantt charts for both the IMS implementation and warehouse expansion, Larry Jeffers race cars can ensure a well-coordinated and measurable transition, keeping their operations on track for efficient growth. Larry Jeffers race cars, project risk management scenario examples. Scenario 1, delayed parts delivery for new race car model. Risk: delay in receiving critical parts for the assembly of the new high-performance race car, Model X1. Qualitative analysis. Probability: medium. Supplier has a history of occasional delays. Impact: high. Delay in launch could result in lost sales and the market share. Timeline: month 2. Parts are scheduled to arrive. Need to monitor progress closely. Quantitative analysis. Decision tree analysis. We explore different scenarios and their costs. On-time delivery, 50% probability, no impact. 1 week delay, 30% probability. Costs associated with expediting shipping and potential production line rework, estimated at $250,000. 2 week delay, 20% probability. Additional costs due to delayed launch, marketing adjustments, and potential customer cancellations, estimated at $1 million. Expected value, $0.50, plus, $0.3250,000, plus, $0.21 million, equals $350,000. Risk response planning. Mitigate: increase communication with the supplier and monitor progress closely. Identify and secure a backup supplier as a contingency plan. Contingency: budget allocation of $350,000 to cover potential expediting costs and launch delays. Scenario 2, key engineer injury during testing. Risk: a key engineer on the X1 model development team is injured during a test session. Qualitative analysis. Probability: low. Safety protocols are in place. Impact: high. Loss of critical expertise could delay project and impact quality. Timeline: month 5, critical testing phase for the X1 model. Quantitative analysis. Monte Carlo simulation. We simulate the potential impact of the engineer's absence on the project schedule, considering factors like knowledge transfer and hiring a replacement. Results show a potential delay of 2-4 weeks. Impact on cost. Estimated cost per week of delay, $150,000, due to production line inefficiencies and potential missed deadlines. Risk response planning. Avoid, enforce strict safety protocols during testing procedures. Mitigate, develop a cross-training plan for engineers to share critical knowledge. Identify potential temporary replacements within the company or through contract hires. Contingency, budget allocation of $300,000 to $600,000 to cover potential delays caused by the engineer's absence. Scenario 3, new regulation on racing fuel. Risk: a new regulation regarding the composition of racing fuel is announced mid-development of the X1 model. Qualitative analysis. Probability: medium. Regulatory changes are anticipated in the racing industry. Impact: medium. Modifications to the engine and fuel system may be required. Timeline: month 3. Regulations are expected to be finalized. Quantitative analysis, not applicable due to the uncertain nature of the regulations' specifics. Risk response planning. Mitigate, closely monitor regulatory updates and maintain communication with governing bodies. Design the X1 model's engine and fuel system with adaptability in mind to minimize modifications. Contingency, budget allocation of $100,000 for potential engineering changes due to the new regulation. These scenarios showcase how Larry Jeffers race cars can use qualitative and quantitative analysis to assess risks, prioritize them based on impact and probability, and develop response plans with measurable contingencies. Remember, the right answer for risk allowance depends on the specific project and risk factors. Larry Jeffers race cars, quantitative risk analysis scenarios. Building on the qualitative risk scenarios from the previous prompt, let's explore how Larry Jeffers race cars can use quantitative techniques to assess these risks and make data-driven decisions. Scenario 1, delayed parts delivery for new race car model. X1, risk, delay in receiving critical parts for the assembly of the new high-performance race car, Model X1. Quantitative analysis, decision tree analysis. We create a decision tree with 3 branches: on-time delivery, 50% probability, no impact; 1 week delay, 30% probability, expediting shipping costs, $200,000, potential production line rework costs, $50,000. Total impact, $250,000. 2-week delay, 20% probability, additional costs due to delayed launch, marketing adjustments, and potential customer cancellations, estimated at $1,200,000. Total impact, $1,200,000. Expected monetary value, EMV, $0.50, plus, $0.3250,000, plus, $0.21,200,000, equals $370,000. Scenario 2, key engineer injury during testing, X1 model, risk. A key engineer on the X1 model development team is injured during a test session. Quantitative analysis, Monte Carlo simulation. We simulate the potential impact of the engineer's absence on the project schedule using a Monte Carlo simulation tool. We consider factors like knowledge transfer time, hiring a replacement, and potential delays in critical tasks. The simulation results show a range of potential delays from 2 to 4 weeks. Impact on cost. We estimate the cost per week of delay, $180,000, due to production line inefficiencies and potential missed deadlines. Metrics and considerations, probability distributions. We used probability distributions, for example, uniform distribution, to represent the uncertainty associated with delays and costs in the decision tree and Monte Carlo simulation. Sensitivity analysis. We can perform sensitivity analysis to see how the EMV or project completion date changes based on variations in key assumptions, for example, probability of delays, cost per week of delay. Confidence levels. When presenting the results, we can specify confidence levels, for example, 90% confidence interval, for the estimated impact on cost and schedule. Risk mitigation strategies. With quantitative data, Larry Jeffers race cars can use the quantitative data to make informed decisions about risk mitigation strategies. For the parts delay scenario, with an EMV of $370,000, allocating a contingency budget of $400,000 might be appropriate to cover potential expediting and rework costs. Knowing the potential cost impact per week of delay from the engineer injury scenario allows for a more informed decision about expediting the replacement process or reassigning tasks within the team. These scenarios showcase how quantitative risk analysis with Larry Jeffers race cars can provide a more data-driven approach to risk management, enabling better decision-making for project success. Perform quantitative risk analysis process in project management. This summary is based on the provided lesson transcript. Purpose: estimate the overall impact of risks on project objectives. Evaluate the likelihood of achieving project goals. Determine contingency reserves for budget and timeline. Requirements: complete and accurate project objectives. Identified risks on individual project elements. Inclusion of generic risks affecting the whole project. Implementation: uses Monte Carlo simulation to analyze the combined effects of multiple risks. Helps predict probability of meeting project objectives. Contingency reserve needed. Risks with the greatest project impact. Project succeeding risk tolerance. Comparison: qualitative versus quantitative risk analysis. Qualitative, descriptive analysis of individual risks. Assesses discrete probability and impact. Prioritizes risks for treatment. Leads to quantitative analysis. Quantitative, predicts project outcomes based on combined risk effects. Uses probability distributions for cost and schedule. Estimates success likelihood and contingency needs. Identifies high-impact risks. Critical success factors, CSF, for perform quantitative risk analysis process inputs, risk register, risk management plan, cost management plan, schedule management plan, enterprise environmental factors, organizational process assets, lessons learned, Tools and techniques, data gathering and representation techniques, quantitative risk analysis and modeling techniques, expert judgment outputs, project documents, updates with overall impact on project objectives. Example, construction project and union strike, potential strike identified. Analyzes project areas most impacted, foundation, transport. Uses sensitivity analysis to inform risk mitigation strategies. Characteristics of tools and techniques, comprehensive risk representation, considering opportunities and threats. Risk impact calculation, on overall project objectives. Probability models, for example, Monte Carlo simulation. Data gathering tools, assessing historical data, expert opinions. Effective presentation of results, probability of success, contingency reserves, critical risks. Iterative process, repeated as the project progresses. Basic principles of probability, sum of probabilities of all events equals 1, 100%. Probability of a single event, 0. Let's use Larry Jeffers race cars, LJRC, to reteach the concept of a work breakdown structure, WBS, for a project. Imagine LJRC is building a new high-performance engine from their dragster. Here's how a WBS can break down the project into manageable tasks. Project, develop high-performance engine for dragster. Milestones. Tasks. Owner. Notes. Engine design. ENGO1. Design engine block and cylinder heads. Lead design engineer. Engine design. ENGO2. Specify engine components, camshaft, pistons, etc. Engine specialist. Engine design. ENGO3. Finalize engine assembly specifications. Lead design engineer. Project manager. Engine assembly. ASSMO1. Source high-performance engine components. Procurement specialist. Engine assembly. ASSMO2. Machine custom engine components. Machinist. Engine assembly. ASSMO3. Assemble and test engine. Engine assembly team. Engine testing. Test O1. Conduct dyno testing and performance analysis. Engine test engineer. Engine testing test O2. Analyze engine data and refine design, lead design engineer. Engine specialist. Engine testing. Test O3. Finalize engine build and documentation. Project manager. Drive_spreadsheet export to sheets explanation. This WBS breaks down the project into 3 main milestones: engine design, engine assembly, and engine testing. Each milestone has 3 relevant tasks, further detailing the steps involved. Each task has an assigned owner based on their expertise and role within LJRC. Notes provide justification for the owner assignment and additional details about the task. This WBS serves as a roadmap for LJRC's engine development project. It identifies key activities, responsible individuals, and potential areas of focus, like performance targets. Additional considerations. Estimated durations. You can add a column for estimated durations, in days or weeks, for each task to aid in project scheduling. Dependencies. Some tasks might rely on others being completed first. Noting these dependencies helps ensure a smooth workflow. For example, engine assembly cannot begin until components are sourced, ASSMO1, by incorporating a WBS into their project planning. LJRC can approach engine development in a structured and organized manner, increasing their chances of success. Launching the project planning phase. Summary with enhanced Larry Jeffers race cars, LJRC, example key activities, build project schedule, create a detailed timeline using project management software like Gantt charts. This schedule will outline key milestones for LJRC's engine development project, including target dates and dependencies between tasks. Set project budget, determine the total financial resources required for the project. This includes material costs, for example, high-performance pistons, $2,500 per set, lightweight aluminum block, $8,000, labor costs, for example, design engineer, $1,000 per day, machinist, $700 per day, with estimated hours allocated for each task. Contingency budget, 10% of total project cost, to account for unforeseen expenses. Prepare risk management plan, identify potential risks that could impact the project, such as part delays, mitigation, identify and secure multiple vendors for critical components, unexpected technical challenges during engine assembly, mitigation, schedule buffer time for troubleshooting and adjustments, cost overruns, mitigation, implement cost-saving measures like exploring alternative materials or negotiating with vendors, Conduct project kickoff meeting. Organize a meeting with the LJRC project team and stakeholders, sponsors, investors. The goals are to establish a shared vision, clearly define the project's overall purpose, which is to develop a high-performance engine that increases LJRC's dragster's quarter-mile race time by 0.5 seconds compared to the previous season. Align on scope, ensure everyone agrees on the project's deliverables. This includes a fully assembled and tested engine, but excludes modifications to the existing dragster chassis. Build rapport, foster a collaborative and trusting environment within the team through team-building exercises and open communication channels. Ask questions, address any concerns or uncertainties team members or stakeholders might have regarding the project goals, timeline, or budget. Set expectations, clearly outline roles, responsibilities, deadlines, and communication protocols for all parties involved. Project management tools, milestones. These represent significant achievements within the project schedule. An example for LJRC could be, Milestone 1, complete engine design, target date, May 1st. Measurable criteria determine completion, such as finalized engine specifications with a projected 20% horsepower increase and a weight reduction of 15% compared to the previous engine. Tasks. These are the specific activities required to achieve each milestone. Breaking down milestones into tasks helps with project planning and resource allocation. Some examples for LJRC under Milestone 1 could be, Task 1.1, design engine block using CAD software to optimize power-to-weight ratio, duration, 5 days. Task 1.2, conduct simulations to analyze engine performance and identify potential weaknesses, duration, 3 days. Task 1.3, finalize engine assembly plan considering manufacturability and maintainability, duration, 2 days. Work breakdown structure, WBS. The WBS organizes the project into a hierarchical structure, visually depicting how milestones are broken down into smaller tasks. A WBS for LJRC's engine development project could look like this. Project, develop high-performance engine for dragster. Milestones. Tasks. Owner. Notes. Engine design, target date, May 1st, ENGO1, design engine block and cylinder heads. Lead design engineer. Utilize CAD software to optimize power-to-weight ratio, target, 20% HP increase, 15% weight reduction. Engine design. ENGO2, specify engine components, camshaft, pistons, etc. Engine specialist. Select high-performance components to meet design goals, consider factors like strength, durability, and weight. Engine design. ENGO3, finalize engine assembly specifications. Lead design engineer project manager. Integrate component selections into a complete engine assembly plan. Engine assembly, target date, June 1st, ASSMO1, source high-performance engine components. Procurement specialist. Identify reputable vendors for specialized parts, prioritize quality and performance within budget, target cost, $20,000, engine assembly. ASSMO2, machine custom engine components. Machinist. Utilize CNC machines for precision manufacturing as needed. Engine assembly. ASSMO3, assemble and test engine. Engine assembly team. Follow assembly specifications and quality control procedures, conduct initial performance tests on a dynamometer. Summary of launching the project planning phase, key activities, build project schedule, set project budget, prepare risk management plan, conduct project kickoff meeting, meet with team and stakeholders, establish shared vision, align on project scope, build rapport or ask questions, set expectations, milestones, important points within the project schedule, indicate progress, tasks, activities needed to be accomplished within a set time frame. Work breakdown structure, WBS, breaks down milestones into manageable tasks, records the breakdown of tasks. Summary of the planning phase in project management with Larry Jeffers Race Cars, LJRC, example with enhanced details. Key activities. Define project scope. Problem: LJRC's current dragster completes a quarter-mile race in 10.2 seconds. They need to shave off at least 0.5 seconds to be competitive in upcoming races. Project goal: develop a high-performance engine that increases the dragster's quarter-mile race time to 9.7 seconds or faster. Target improvement, 5%. Deliverables: fully assembled and dyno-tested high-performance engine achieving a minimum of 220 horsepower, baseline, 180 horsepower. Documented engine assembly specifications and performance data. Risk management. Risk: Parts delays from suppliers could hold up engine assembly. Likelihood, medium, impact, high. Mitigation, identify and secure 2 qualified vendors for critical components, for example, pistons, camshaft. Establish clear communication channels and set safety stock levels to minimize delays. Risk, unexpected technical challenges during assembly might impact performance or reliability. Likelihood, medium, impact, high. Mitigation, schedule buffer time, 10% of total project duration, for troubleshooting and adjustments. Conduct stress simulations during the design phase to identify potential weak points. Project schedule. Deadline, the engine needs to be completed and tested before the first race of the season. Target date, June 1st. Work breakdown structure, WBS, break down the project into smaller tasks with estimated durations and assigned personnel, for example, design engine block, 4 days, lead design engineer. Utilize project management software to visualize task dependencies and track progress. Resource allocation, assign tasks to team members based on their expertise, for example, lead design engineer, machinist, quality assurance tester. Estimate labor costs associated with each task for budget planning. Testing plan. Testing methodology, conduct a series of dynamometer tests to measure horsepower, torque, and fuel efficiency across various engine RPM ranges. Success criteria, the engine must achieve, minimum of 220 horsepower at peak RPM, measured increase of 22% from baseline. Torque exceeding 150 pounds-feet across a usable RPM range, improvement of 10% from baseline. No signs of overheating, excessive vibration, or oil leaks during extended testing. Benefits of project planning for LJRC. Increased chance of success, by defining measurable goals, identifying risks with mitigation plans, and creating a detailed schedule, LJRC is more likely to develop the high-performance engine within the designated timeframe and budget. Improved communication and collaboration, a well-defined plan fosters better communication between team members regarding tasks, timelines, and potential roadblocks. Early problem identification, proactive risk management allows LJRC to anticipate potential issues and develop solutions before they significantly impact the project. Measurable progress tracking, with clearly defined milestones, testing criteria, and a WBS, LJRC can effectively track progress, identify areas needing adjustments, and ensure they stay on course to meet their goals. Consequences of poor planning for LJRC. Project delays, without a clear roadmap. LJRC might miss deadlines due to unforeseen challenges or misunderstandings about task dependencies. This could lead to a last-minute rush, compromising engine quality and performance. Cost overruns, unforeseen expenses due to part shortages, inefficiencies, or rework could strain LJRC's budget. Poor planning might also lead to underestimating labor costs. Subpar performance, rushing the development process or overlooking critical testing could result in an engine that doesn't meet performance goals. This could put LJRC at a competitive disadvantage. Team morale decline, miscommunication, delays, and unmet expectations can lead to frustration and reduced motivation among team members. By investing time and effort into thorough project planning with clearly defined goals, measurable metrics, and risk mitigation strategies, LJRC increases their chances of developing a high-performance engine that propels them to racing victory.